Hello students, today we are going to study crushing and abrasion test of aggregate. Aggregate crushing value test on coarse aggregate gives a relative measure of the resistance of an aggregate crushing under gradually applied compressive load. Coarse aggregate crushing value is the percentage by weight of the crushed material obtained when test aggregates are subjected to a specified load under standardized condition. Aggregate crushing value is a numerical index of the strength of the aggregate and it is used in construction of roads and pavements. Crushing value of aggregate indicates its strength. Lower crushing value is recommended for roads and pavements as it indicates a lower crushed fraction under load and would give a longer service life and a more economical performance. The aggregates used in roads and pavement construction must be strong enough to withstand crushing under roller and traffic. The objective of this test is to determine the aggregate crushing value of coarse aggregate as well as assess suitability of coarse aggregate for use in different types of roads. Now the apparatus used in this test are a steel cylinder 15 cm diameter with plunger and base plate, a straight metal tamping rod 16 mm diameter and 45 to 60 cm long rounded at one end, a balance of capacity 3 kg, readable and accurate to 1 gram, IS sieve of sizes 12.5 mm, 10 mm and 2.36 mm. Next apparatus is a compression testing machine, cylindrical metal measure of sufficient rigidity to retain it from under rough usage and of 11.5 cm diameter and 18 cm height. And the last one is dial gauge. Procedure of aggregate crushing value test. Put the cylinder in position on the base plate and weigh it W. Put the sample in 3 layers, each layer being subjected to 25 strokes using the tamping rod. It means that we have to fill the aggregate in 3 layers and each layer being subjected to 25 strokes by the tamping rod. Care being taken in the case of a weak material not to break the particles and weigh it W1. It means that we have to take care during the tamping of the material that it does not break, okay, and let the weight of the sample be W1. Level the surface of aggregate carefully and insert the plunger so that it rests horizontally on the surface. Care being taken to ensure that the plunger does not jam in the cylinder. Place the cylinder with plunger on the loading platform of the compression testing machine. Apply load at a uniform rate so that a total load of 40 ton is applied in 10 minutes. Release the load and remove the material from the cylinder. Sieve the material with 2.36 mm IS sieve, care being taken to avoid loss of fines. Weigh the fraction passing through the IS sieve and let it be W2. This is the apparatus of the aggregate crushing test. Now the calculation of aggregate crushing value. The ratio of weight of fines formed to the weight of total sample in each test shall be expressed as a percentage, the result being recorded to the first decimal place. So aggregate crushing value will be equals to W2 into 100 upon W1 minus W, where W2 is the weight of fraction passing through the appropriate sieve and W1 minus W is the weight of surface dry sample. The mean of two results to the nearest whole number is the aggregate crushing value. Now for solving purpose, the aggregate crushing value will be equals to 50. For water-bound macadam, the aggregate crushing value will be equals to 40. Similarly for bituminous macadam, 40. For bituminous surface dressing or thin premix carpet, it will be equals to 30. For dense mixed carpet, it will be equals to 30. Now for rigid pavement other than wearing course, the aggregate crushing value will be equals to 45 and for surface or wearing course, it will be equals to 30. Now the next test is the abrasion test. Abrasion test is carried out to test the hardness property of aggregates and to decide whether they are suitable for different pavement construction works or not. The principle of Los Angeles abrasion test is to find the percentage wear due to relative rubbing action between the aggregate and steel balls used as a abrasive charge. Now this is the Los Angeles abrasion testing machine. Now apparatus required will be balance. Balance should be accurate up to 1 gram. It means that it should measure up to 1 gram precisely. Now the next apparatus is sieves. Sieves required are 80 mm, 63 mm, 50 mm, 40 mm, 25 mm, 20 mm, 12.5 mm, 10 mm, 6.3 mm, 4.75 mm as per gradation of aggregate and 1.7 mm. Next is the Los Angeles testing machine. Inside length equals to 50 centimeter and inside diameter equals to 70 centimeter. And the other one will be the abrasive charges, that is the steel balls, diameter equals to 48 mm and weight equals to 390 to 445 grams. Now the procedure of abrasion test. First one is gradation of aggregate. Gradation of aggregate should be carried out so as to assess the grade of the aggregate A to G. Now in this table, in the first column, sieve size is written, that is the passing sieve and the sieve on which the material will be retained out, and in the next column the grade of aggregate is written with weight, that is passing sieve is 80 mm, retained sieve is 63 mm, and for grade E type aggregate the weight of the test sample in gram will be equals to 2500 grams. Similarly for different types of grades, weight will be written here like this. Okay. Now the next one will be the procedure for Los Angeles abrasion test. The test sample shall consist of clean aggregate which has been dried in an oven at 105 to 110 degrees Celsius to substantially constant weight and shall conform to one of the gradings shown in table 1. The grading or gradings used shall be those most nearly representing the aggregate furnished for the work. The test sample and the abrasive charge shall be placed in the Los Angeles abrasion testing machine and the machine rotated at a speed of 20 to 33 revolutions per minute. For grading A, B, C and D, the machine shall be rotated for 500 revolutions. For grading E, F and G, it shall be rotated for 1000 revolutions as mentioned in this table. Now for A type aggregate, the number of spheres required is 12 and weight will be equals to 5000 plus minus 25 grams. Similarly for B, C, D, E, F and G, number of spheres is written here and weight of charge in grams is written here. Now the next step is the machine shall be so driven and so counterbalanced as to maintain a substantially uniform peripheral speed. If an angle is used as the shelf, the machine shall be rotated in such a direction that the charge is caught on outside surface of the angle. At the completion of the test, the material shall be discharged from the machine and a preliminary separation of the sample made on a sieve coarser than the 1.70 mm IS sieve. The material coarser than the 1.70 mm IS sieve shall be washed, dried in an oven at 105 to 110 degrees Celsius to a substantially constant weight and accurately weighed to the nearest gram, that is B. Now the calculation of abrasion test. The difference between the original weight and the final weight of the test sample is expressed as a percentage of the original weight of the test sample. This value is reported as the percentage of wear. Now aggregate abrasion value can be determined as A minus B divided by A into 100, where A is the weight in gram of oven dried sample and B is the weight in gram of fraction retained on 1.70 mm IS sieves after washing and oven dried up to constant weight. That is all about the crushing test and abrasion test of aggregates. Thank you, students.